Hello everyone and welcome to my channel. Today we are diving into exciting topic that is essential for everyone working with artificial intelligence, key parameters of large language models. Whether you are using a large language model like Google Gemini, ChatGPT, Bloom or others, understanding these parameters can unlock the full potential of these incredible generative AI models. As you know, the large language models are like a versatile tools that can be tailored for different tasks such as text summarization, generating images, and even generating the code. But how do you control them to ensure they produce accurate, creative, or task-specific outputs? So that's where key parameters like temperature, top K, top P, and the stop sequence, and additionally frequent analysis comes into this play. These settings let you shape the model's behavior and guide it to generate exactly what you need. So in this video, we are going to define about temperature, briefly explore on other parameters as well, and how do the temperature works with large language models, benefits of adjusting temperature, and understanding the temperature settings to the suitable tasks, and hallucination at various temperature settings, and mastering the temperature in prompt engineering. So, coming to this temperature parameter in large language models, so the temperature is a key parameter that affects how confident or creative or diverse the large language models is. In simple terms, temperature is a parameter that controls the randomness of large language models output. It adjusts the probability distribution of the predicted words. Okay. So there are different settings available in temperature, that is a low, medium, and high. So in low temperature, it encourages the model to choose high probability words, making responses more predictable and conservative. And also low temperature values makes the model deterministic and focusing on the highest probability outputs. Coming to this high temperature, flatten the probability distribution, encouraging the model to consider a broader range of possible words, leading to more wide and unexpected responses sometimes. And high value temperature produces more diverse and creative output by assigning higher probabilities to less likely words that are called indirectly tokens. Okay. So coming to the practice session, this is a Google's Gemini dashboard. Now we are jumping into Google's Gemini playground of uh, chat. Okay. So Google providing a free coins, like free coins to do a practice at the time of learnings. Okay. So in this Google Vertex AI, there is a option called free form. You can do more practice for your learnings in the prompt engineering. So this is a dashboard. It has the parameters in right side. It is showing. So currently it's not showing any parameters. Why? Because we have to choose the different types of models that are available in a drop down list. Okay. So here we can find more model variants with the different parameters. See this. Now you are able to see the parameters here. So like Google's Gemini, OpenAI's ChatGPT also producing the playground for doing the chat conversations. It has also a most of the same set of options available in this playground. And you can also choose the different model variants, that LLM model variants from 3.5 turbo to 4.0 mini and all. Okay. So now let's jump into this Google Vertex AI Gemini practices. Okay. So in this, when temperature comes to this picture, it has variant levels. For example, see this. I'm just asking this to this Google Gemini to complete the sentence. Hey, the sun was setting over the horizon and I'm setting the temperature to 0.2. Okay. Every time we are for practicing, we are just setting up our customized settings, the temperature. So now just click on this to generate the response. See this. This is the response we have received from the Google Gemini and the temperature of 0.2. So the sky is erected and breaking through display of the fairly oranges and pinks and purples. So just reminder this prompt, this response at the stage of 0.2. Now I am changing this to high temperature from 0.2 to 1. Let's reproduce the response to the same prompt. See this. Earlier, the response and this response are slightly changed. This is how the temperature predicts and increase or decrease the randomness of the LLM's response. Okay. So coming back to this rest of parameters in the large language model, the top K limits the model predictions to the top K most probable tokens or that are words. For example, if top K set the count as a 10, the model will only consider the top 10 mostly likely words that are tokens for each prediction and ignores the rest. That means it's only limited to the 10 tokens, most likely words that are tokens and most likely words. Coming to this top P, this parameter controls the diversity of a word choice in generated text. Instead of fixing a number of tokens like top K, as it is exampled as a 10, and top P selects the smallest set of tokens whose cumulative probability is greater than or equals to the top P settings. In general, the default setting is 0.95 in a Google Gemini. Okay. And a presence penalty. This parameter discourages the model from repeating words or topics that it has already used in the same response. It helps to reduce the token utilization and saves your cost. And also frequency penalty. See this frequency penalty. Here, see this. Few options are available in OpenAI also. In frequency penalty, this parameter discourages the model from repeating the same words frequently within the single response. In that same response, if the model is trying to repeat or use the same words, this frequency penalty controls and save your tokens as well. And the stop sequence. Stop sequence is also one of the token controller, and it defines a specific tokens or phrases where the model should stop generating. This ensures the output ends cleanly without unnecessary contents. You can use the stop sequence as a hash, comma, or dot. Okay. So coming back to this temperature, how it works in large language models. So when generating the text, the model predicts the probability of each possible next token, that is a word. Temperature adjusts these possible probabilities to their increased certainty by making high probability words even more likely at a low temperature, and increased diversity of leveling out probabilities, making it more likely to pick a less common words at high temperature. This is how looks like. For example, in this example, the cat is at a high temperature or low temperature. These are a probability words internally it predicts. So in most of the cases, the cat is on. This is a high probability, or sometimes less probability than 40%. The cat is sleeping. This is how large language models predict the next token by following the temperature settings. So when it comes to the low temperature, the same sentence, the cat is on. See this, at low temperature, the predictions the predictions are deterministic and focus on the prediction of the output from the LLM. At high temperature, it flattens the distribution and spread probability across broad tokens, that are broad words. That's the reason the same word at high temperature, it fills with a on or sleeping. It's already changing the probability percentages. This is how temperature change the prediction itself in the large language models. Okay. And coming to this, why we need this temperature in large language models. So temperature, as you know, the temperature controls the randomness and creativity of large language models responses. To balance between generating the predictable factual output and exploring the creativity and diverse possibilities. That's why we need a temperature settings to generate a accurate and coherent responses. Okay. So when it comes to the predictability in the context where accuracy and coherences are important for a factual responses or technical answering or any text summarization tasks, in the low temperature, it ensures that model sticks to common and reliable choices. And when it comes to the creativity at high temperature, it generates stories, poem, and brainstorming ideas, and also exploratory and original responses. And it produces more random and diverse outputs, sampling from a broader range of possible tokens at high temperature settings. Okay, this is the high temperature settings. Okay. And coming to this section, benefits of adjusting the temperature in different versions. So when it comes to the benefits, adaptability. LLMs can tune for a different types of tasks using temperature. The low temperatures are suitable for clear and factual outputs, while the higher temperatures are encouraging creative content generation like poems, exploratory or experiment tasks, and the stereotypic tasks. And also the controlled creativity, while doing a fine tuning the model's output based on the task requirement, that low temperature produces a deterministic output suitable for the factual precise tasks like a code generation and knowledge retrieval. Okay, and high temperature promotes exploration of diverse token combination and ideal for creative writing and brainstorming ideas. And also another benefit is improving the task suitability. That means customizing the output by style for a domain specific applications. Here the domain specific applications like healthcare, marketing, finance, legal, insurance, and other industries or other domains. And also enhance user experience, aligns output with a user expectations. By doing the temperature settings at various levels, the user can get a accurate and expected output from the large language models. Okay, and also sometimes we can try the output with the hybrid settings, that combination of temperatures with top K, top P, and that enables even more precise controls for the expected response from the large language models. So, in order to understand the temperature settings for the various tasks, this is that temperature is uh, as you know, the temperature is also a key parameter that controls randomness of the model's output. It essentially determines how much models deviates from its most likely predictions. Okay. So when it comes to the low temperature, this low temperature mostly the objective is generate accurate, concise, and precision and deterministic outputs. This is suitable for factual summarizing, translations, code or programming generations, and question and answering tasks, and document summarizations as well. In medium temperature, that is 0.5 to 0.8, that objective is generate a professional and engaging content. Okay, and it's more suitable for creative writing, dialogue generations, product descriptions for the retail stores or online e-commerce websites or other tasks, and essay writing as well. And also in the form of marketing industry, we can use the more engaging and eye-catchy ad copies, like using the Google Ads or other social media platforms. Okay. In high temperature settings, that's objective is produce the diverse and imaginative content to the user, and also it's sometimes you can generate a stereotypic content as well. This high temperature you can use to generate the brainstorming ideas or poetry generations or script writing or storytelling or experimental tasks. Okay, let's have the examples. So coming to this low temperature settings, so now we are going to test this at low temperature. So I'm just changing the settings from 1 to 0.2 or 0.3. Okay, so let's get the response from the Google Vertex AI. That means that's indirectly a Gemini model. See this. What I ask, summarize the key cause of climate changing in 50 words. This is how the response generated by the Google Gemini at the temperature 0.3. Okay. In the same, at medium level, I'm just changing it to 0.8. Okay. Let's see the response. The same prompt. See this. So earlier it produced the different version, and this time also producing the unique other version. So both are different. Okay. And also we can try with the highest temperature, that is 2 in Google Gemini. This is the highest temperature, maximum temperature you can set in a Google Gemini. Let's see the response from Google Gemini at highest. We are using the model of 1.5 flash. See this response. That response is also a different. This is how temperature changes its response based on your customized settings. So in the next concept, we are diving into the hallucination in temperature settings. So in the context of large language models like Google Gemini, ChatGPT, Bloom, hallucination refers to the phenomenon where the model generates false or nonsensical or factually incorrect information that sounds believable by the users. Okay, the temperature parameter is LLM plays a crucial role in controlling the diversity and the randomness of output, which can influence the hallucination at any temperature levels, maybe low temperature or high temperature as well. So In low temperature, also there is a possibility to generate hallucinated content as a output. The model strongly favors high probability tokens, resulting in a deterministic and focused outputs at a low temperature. Even though when you are doing a when you are doing fine when you are doing pre-training your large language models, the fine-tuned model's lack of knowledge or it has been trained on a incomplete or prompt with ambiguity words. Okay. And comes to the high temperature, there is a high possibility that can generate a hallucinated content that are hallucinated output. So the model samples widely from the distribution, often selecting a low probability tokens that are words. That model is prone to generating a nonsensical or completely fabricated information. So in these two comparisons, where hallucination at high level means generates means at high temperature there is a high probability to generate the hallucinated content. Let's see the examples. So now I am just asking the Google Gemini at low temperature. Let's see the response. So I'm just repeating 0.5. Okay. I'm just setting up the temperature 0.5 and see the response. So Atlantis is a fictional Iceland civilization. Therefore, it doesn't have any real capital city. Actually, it is responded, but we are just expecting the hallucinated outputs. So this way we can practice the hallucination with the different temperature settings. Okay, low, medium, and high. And also to mitigate this hallucination, there is some technique use that is called reinforcement learning from human feedback. That is called in short RLHF. Fine-tuning the model to align with a human preferences, that is called human touch, minimizing the human hallucination risk across all temperature settings. And also knowledge augmentation. So integrate the external knowledge sources like API or vector databases to ground the model's output in facts most of the time. Okay. And also by doing the chain of thoughts. So chain of thoughts is responding your output in a reasoning model in a step-by-step process. By breaking down the task into smaller steps to reduce the likelihood of hallucination. For example, instead of asking a just writing a full essay in one prompt, guide the model with a step-by-step instructions to complete the task essay writing. Okay. So this is how you can mitigate the hallucination in large language models. And coming to this, mastering the temperature in prompt engineering. So in prompt engineering is a process of giving instructions to the large language models to control the outputs. Okay. So in this process of prompt engineering, by doing the different settings of the temperature, you can find and generate a output what the user expecting. That means you are expecting. So by doing the iterative testing, the user definitely will generate a expected output. Okay. So experimenting with the different temperature values for a single prompt to observe how model output changes. So you can practice from 0 to 1.5 or 2 in Google Gemini model also. And in another, pairing with other parameters. So the temperature can be paired with top P and top K, more control over the randomness. These are the practices you can do, we can do while doing the large language model outputs. So finally, coming to this sample practices with the combination of other parameters. So we can try these practices with the different tasks like translation or question and asking or programming or summarizing. So based on the level of temperatures, the large language models can generate, categorize the tasks. This is how we categorize, and we can use the different levels of temperatures for various tasks. Okay. So now I am going to test this temperature. So first we'll try this low temperature practices. Okay. The temperature is 0.2 at 0.5, and top P is 0.95, that is high, and it's actually a default value by unfortunately there is no changes in the top K. Okay, but we can change to top P. What is the top P value? Top P value is 0.8. Okay, we are changing it to 0.8. Okay, so now we are asking the example. So we are asking the question in the Google Vertex AI. What is the uses of black hole in physics? Okay, the temperature is 0.4 and the top P value is 0.8. Let's see the response. Now we are doing a combination by combining the other parameters as well. This is the response Google Gemini generates with these current settings. Let's go to the other settings. These are like a balancing settings. Let's set up the settings as 0.6, temperature as 0.6, and I am changing the model for different version as well. It is an experiment level, and this is to 9. Okay, as guided. So now we are just doing the same response with the same prompt. Let's see the output. This is the response. Just have a look. High energy, anthropics, and anthrophysics, and cosmology, and this. Let's click on this. See this. That response is completely changed by changing the parameters. Values, parameter values. Okay, it is still generating and it's completed. And finally, we can try with the high temperature with the high top P value, and the top K value is by default is 40. Okay, so actually we'll try with the 1.5, and also you can control the maximum number of tokens it can generate. Okay, so if you control to 200, the maximum number of tokens it can generate up to 200, including input. So tokens are counted including input and output tokens. Okay, so it's a 9.95, 0.95. So now we are testing the final practice, that is creative task. The temperature is 1.5, as we can able to do in a Google Gemini, and the top P value is 95. Okay. And also I have customized the output token limit as well to 200. Now click on the response, the same prompt. Check for the response. See this. So earlier it has a small description. Now it is described more. In this case, actually, as per the instructions you have provided with a high temperature and the top p value is also high, it's generated a lengthy paragraphs. Earlier, if you see, just assume it's a paragraph is 5 lines only. Now this paragraph is generated 8 lines. So in this practice, at high temperature, the tokens utilization is also very high. The tokens consumption is also very high. That means it costs you while you are doing a practices, okay, in real time. Okay. So that's the reason try to do a practices at low and medium temperatures to utilize the maximum number of tokens for your further practices. Okay. So thank you guys. If you found this video is helpful, please do like and subscribe and drop your thoughts in the comment section. Thank you. Have a good day.